All right, I'm starting. How about that? 12:32. Thursday. That's what it is. It's not garbage day. Still raining though. Did everyone have fun with their first tornado warnings of the season on Tuesday? It was nice and polite to wait until I was finished teaching and with my meeting, and right when I was ready to go home, the sirens started up. So Vladimir and I got to hang out in the basement of this building and see the lovely downstairs accommodations. So, but very cementy, I would say. It's very like hard, like all the surfaces. Yeah, I did feel very secure down there. It's kind of like a little party, a little tornado party. So, but fortunately, no damage as far as I heard this time. But we'll see. Today is not going to be weird though. I can tell. Like if you see it's like green or purple overcast, then or yellow. Yellow is very bad. But today it's just rain, so it's all good. Yeah, it's one of those things as a Midwesterner, you get used to seeing the colors, and that carries additional information beyond the forecast. So, I have a memory when I was in junior high school in the summertime. Like the first summer, my mom let me stay home all by myself, and I remember her calling at like 10:30 in the morning, saying, "It's really green outside. You need to get into the basement." Well, lo and behold, that's where we kept our TV. I was not going to be anywhere else in the house but that basement, so because that's where MTV was. So, covering all my bases. So in case I'm wrong, we'll eject, but I'm not expecting any more excitement today. My excitement comes from having a very brief period of no grading on my desk right now until Monday. So I believe I have made it through everyone's homework 3 revisions and sent either feedback or dropped a note in Icon or both, and I updated grades. If you do not have your feedback and I forgot to send it to you, please let me know and I'll be happy to do that. But I believe I am all the way caught up until Monday when homework 5 is due, and actually in both classes. Both classes are writing things, so it's going to be a fun, grady week. So any homework 5 questions, I'll ask for like the 17th time just to make sure we're clear on that. If you have any about what you're supposed to do, please let me or the TAs know. Vladimir, any questions you've had from folks that we should talk about or no?
No, yeah, because we were talking about like how to interpret results, how to interpret interactions, simple slopes.
Oh, that's the other class, I bet.
Oh, we're in the same.
Yes.
Sorry for that. Yes.
Yep.
Steps. How to do first, how to compare 2PL with 1PL model, and yeah. Yes, Lisa. I
Yes.
have one
Okay.
thing to say.
One thing.
Can you repeat, please? How should we interpret modification indices, and what kind of information should we use?
So in limited information models, is that what we're talking about, IFA?
Yes.
Yeah, so the question was, how do we interpret and use modification indices?
Yes, and when?
And when?
Yes.
So I would say the same principles apply whether you're fitting a CFA model or an IFA model. The modification indices are completely data-driven score tests that will tell you how your chi-square would change as a function of adding model parameters. That does not mean that it's a recipe that you should follow, though. I would say that you would want to look at both the suggestions and the content simultaneously to decide whether the suggestions have merit or whether you think they're just flukes. Ideally, if they have merit, you would see them replicate in additional samples, which would give you further confidence that these are not just, arbitrary modifications. But you would also want to look at the leftover correlations, so the residual correlation matrix, as further information about where specifically your model predictions are off and what you might want to do to remedy that misfit. But the rules for homework 5 are the same. Your goal is not to get a good fitting model at all costs. Your goal is to demonstrate that you can use the information given to make reasonable modifications and that you understand what the parameters are telling you. That's the goal.
Thank you.
Sure. And yes, I get confused as to which class is which, too. It took me like the whole first half of this semester to remember that SEM was first this time. So, yeah, especially when there's so many people who are in both, then it gets extra confusing. So there's no contextual clues. And the content does run together, yes, and that's not a coincidence. So that was one of the reasons why I liked the generalized class sets you up for all of the latent variable variants of the generalized models and the path analysis. So yes, quite a bit of overlap between the two classes too, which does not help. What I was working on today, besides finishing grading, is starting to get your homework 6 ready. So your very last thing this semester is going to be another online data assignment in which you get to practice invariance, both within CFA and within IFA. It will be worth 20 points, so you have to do it to pass this class. Okay, in case anyone's thinking, I'll just skip the last homework and take my B. No, I've made that mistake before. No, you have to at least do some of it in order to pass the class. It's 17 points or computational answers, so if you get at least that far, you know you've got the majority of the points that you need, and then the usual multiple choice questions about interpretation of the model. So I will let you know once that is available to you. It will be due at the end of finals week, so not for, what, 3 or 4 weeks? I forget where we're at. This is 3 weeks of classes. This is the last 2 more weeks after this of classes, then finals, so we're getting there. Questions from the Zoomers: what could be some logical reasons to decide adding modification indices? Usually they would have some kind of extra specific content based on either the context of what is being asked about or else the way the question is being worded. So a classic example would be, items that are reverse coded would potentially have an additional correlation beyond whatever they're supposed to measure because of that. If you have similar wording in things or similar content, then you could make an argument. But if you look at all of the items and there's no theoretical reason why these two should have a covariance and not the others, then I would hesitate to add it. So let's see. Charlotte said 3. Was that a question or an answer? 3 weeks left. I bet that was the answer to that question. That was an answer. Okay, yes, thank you. Gotcha. I got to remember my own questions. So since we're going to be doing invariance on the last homework, how about we finish that unit and then start something new? How's that sound? Sound like a plan? Why not? So we were most of the way through example 7C, which is an IFA invariance testing example. We are testing directly measurement model parameters from the IFA framework, meaning factor loadings, thresholds, and potentially residual variances for items that have their loadings and thresholds constrained. And then we can get to the usual structural invariance constraints. The only catch that makes this process different, other than replacing intercepts and thresholds, is that the model comparisons, when you're using limited information estimation, have to be done with the m+difftest command. So I've highlighted here, at least for the first model, we would have save data, list the name of the file that the results should be saved to, and I would highly recommend making these meaningful labels so that you know what your code means in the future. So I'm saving the results of this model, for instance, as configural.dat, and then in the next version of the model, in which I place metric invariance loading constraints, I then refer back on the analysis line to that configural set of results, and then on save data, I'm saving the current model to be compared back to for future models. So it's this iterative process of save what you have, compare back to the previous one, repeat it as needed. And difftest will yell at you if you get them in the wrong order. So the model that has more parameters has to be first. The nested model with fewer parameters comes second. And in that nested model output, you will see this additional piece right here, chi-square test for difference testing. That is your analog to your likelihood ratio test that you would be doing in a CFA full information framework. So in this example, we went through piece by piece. First step, it looked like we needed to free a loading for item 3. So after doing that, the model fit not worse than the configural model. It looks like in terms of the solution, that item 3 was less discriminating for men than women based on the difference in the loadings, and these are in a probit metric, by the way. Going through the process then of threshold invariance, and just to remind you that when you are constraining thresholds to be equal, that's what this blank space is doing by omission. So this is page 6 of example 7C. We could either write out all the thresholds and label them to match what is above, but because thresholds are a default parameter that get estimated no matter what, the easier way to do it is just to not write anything, and then they are all constrained to be equal. So by omission, we're essentially doing the same thing as applying these labels. That will save you a bit of time, particularly if you have items where the categories aren't all used and you have to figure out exactly which thresholds are even logically possible. At this stage, we would free the factor mean in addition to freeing the factor variance, and then both of the sides of the model, means and variances, are on the same scale. So then we went through the tedious process of trying to figure out which invariance constraints broke the model. Those for item 3 were first, which is not surprising since its loading was already non-invariant. It wanted to be different. Then I added item 3's thresholds. Next round was item 1, threshold 3. Added that one. Next round was item 2, threshold 3. Added that one. And then one more, item 1, threshold 2. And I think that was where we were at. And then we were at the residual solution. So at this stage then, after you're finished with metric and scalar, only then can you have residual variances potentially be estimated in the alternative group. And they cannot be estimated in the reference group. They have to be fixed to 1 for identification. That sets the metric of this as a probit scaling specifically. That's what the parameterization equals theta does. In this stage, it goes logically backwards. So because you have to have the larger model estimated first, the next thing I did is break out of my sequence of increasingly nested models and estimate all of the residual variances in the alternative group except for item 3, because that one did not have its loadings or thresholds constrained. So at this stage on page 12, all we need to do is save these results. Then in the next model, we use the save results and we compare them against the previous model in which the residual variances were all fixed to 1. So this is the part where, honestly, when students have tried this with real data, I've seen this converge maybe a third of the time. Like I routinely see these models blow up at this stage. So if that happens to you, I would not worry about it. You can report that and move on. Residual variances are not even parameters in the full information version of these models. So the fact that they're invariant or not invariant to me is much less consequential in this context, because you can't really separately estimate variance left over anyway. So last step we did then, compare the factor variances across groups after getting through the residual stage. They wanted to be different, so we called it good. And this was where I think we left off. Does that sound about right? Looking at the final solution? Yeah? So I added labels to remind us what each of these things is. And so the story, these are older adults who would have been born in the early 1900s, in which invariance across genders is going to reflect culture as well as individual differences. At the time, there were much more prescribed gender roles in place in society and how people were raised. So we have item 3 is much more discriminating in women than men for cooking. So it's a stronger indicator at its levels of thresholds, or excuse me, at its levels of difficulty. We'll get to difficulties in just a second. In terms of items, it looks like for item 1, the second and third thresholds, so that separates the responses of 0, 1 versus 2, 3, or 0, 1, 2 versus 3, are easier in the alternative group or more difficult. Which way do these go? In the alternative group here, are these thresholds easier or more difficult? I got -4 versus -5 and -0.6 versus -2. Yeah, lower is easier, yes. So easier then in the alternative group means they are less likely to not be able to do it, less likely to fail. These probits translate into very small probabilities of not being able to have a 50-50 probability at that trait level. The same thing is true to an even greater extent for item 3, which is cooking. So much easier items for these in the alternative group, which is women. In terms of structural differences, what are we looking at if I say structural differences? What kind of parameters? Zoomers, you can play along too, as always. Structural stuff, what vocabulary goes with that? What kind of parameters? Factor means, that's one. Factor variance, Zoomers say, is another, and there's one more possible, but it's not part of this example. Starts with a C. Covariance. And why is it not part of this example? Yeah, I don't have any covariances because I only have one factor per group. And these are not partners, they are different people. So there is no dependency that would require us to put multiple factors within the same group. In terms of structural parameters then, the men as the reference group have their mean fixed to 0 for identification. The mean for women is minus 0.38, so they are lower on average in terms of this trait of independent living, even though several of these items are systematically easier for them. Likewise, the alternative group of women in terms of their factor variance is lower than what it is for men. So men are setting the scale of the model as having a factor mean 0, variance 1. Women's factor variance is half that. So women are more homogeneous. They're more alike, as well as having less ability on the average. So I wanted to show you how these things translate into IRT parameters. However, given the factor mean and variance differences, I deliberately re-standardized the theta to mean 0 and variance 1 in both groups to compute A's and B's. Otherwise, even for parameters that are invariant, their IRT versions are going to be different because of the differences in factor means and variance. So to be able to try and put these on a comparable metric in terms of what the A and B parameters would be from this solution, I did it this way. And I made some pictures here. So this first top left picture on slide 15, these are the thresholds. And I have it set up by color as to which threshold it is in the model. So the transition point from an answer of 0 versus 1, 2, 3 as having 50-50 probability of those actually, nope, hang on. Yeah, that's the first threshold. This is the amount of theta needed to transition out of 0 into 1, 2, or 3 for men or women, or out of 0, 1, or out of 0, 1, 2. And the dashed lines show the parameters for women. And so when the lines overlap, then those are the same. So you can see from this that item 3 in particular has a lot lower thresholds, meaning it's a lot easier for women. If we put it into difficulty, the differences are a little more compressed, but they're still the same pattern. So in item 2, the third threshold, item 1 in the third threshold, and then in item 3, all 3 thresholds are systematically easier for women. And how did I get these numbers, or how could I get them out of M+? A whole bunch of code. I don't know why they don't give these to you. They give them to you in the binary case, but they don't give them in the ordinal case. So here's what I did as a separate file to be able to generate all of these things. We have the model for men as the reference. We have the final result of the model for women, in which I've added W's to the individual thresholds that wanted to be different, as well as the individual loadings that wanted to be different. I then used model constraint to compute A's and B's in the same way that I did in example 6A, just with 2 different groups. So I have 2 sets of A's and 2 sets of B's. And for those of you who have different numbers of thresholds across your items, you may end up having to do abbreviated loops that look something like this. So for instance, because item 3 was different in this group, I couldn't loop all the way through without changing what it's called. So I looped over 1 and 2, I did 3 myself here, and then I looped from 4 to 6. So I think, I was talking to you yesterday about this, right? Yeah, so you'll have to do this sort of abridged, like filling in the gaps to make it work if not all items have all thresholds. It can be a little bit tedious, but otherwise it's okay. So then I get this additional output, which not only gives me the point estimates for all of these things, but their standard errors as well. And yeah, and then we get words. So in terms of these difficulties, to me, I think this has a very pragmatic application. Like if you are a care provider and you're trying to assess someone's susceptibility to injury or fall from living alone, or their capability to do so, the fact that we have non-invariance, the fact that we have, what would IRT people call it? What is non-invariance called in IRT land? Yes, differential item functioning. That's what I would call these things. It is uniform diff for items 1 and 2 because their loadings are constrained to be equal. It's non-uniform diff for 3 because it's both loadings and thresholds that needed to be different. And so these are the corresponding B values that come out of that. What this would tell me is that if I'm evaluating somebody, I would need to know their gender as part of the story as to how well they're able to live independently. Because if you are a woman and you can't cook, that's really bad. If you are a man who can't cook, that's like, could be okay, could be not. So it may be the case that in practice, for certain kinds of people, that certain types of items are more informative or systematically more easier or more difficult. And so the fact that these are different isn't necessarily a problem per se, but it's something that you would want to keep in mind when you think about how to process the scores and the responses from these people. Like if you were fitting a full-on structural equation model where you were looking at gender differences in this trait and other things, you could just let these items be non-invariant, just let them differ across groups. That way you're not assuming that they function the same way when we have evidence that they don't. So, and all of these plots and things that I made, they're in the Excel sheet that goes with this example as usual, or you can make your own as you see fit. And there's some words that describe all of this in way too much detail as usual. There. How's that? Not so bad, right? It's tedious, that's what it is. It is, I'm not going to lie to you. There are, particularly within the IRT world, there are algorithms that can automate some of this. So within IRT packages that examine differential item functioning, there are options to try like all possible combinations until you land on like the best solution. And there's research on, you know, what the optimal strategies are for this kinds of things. I'm just showing you sort of the generic version that would be more common in the SEM CFA world. This is the extension to the categorical world. So it is tedious, but once you get to know what you're doing, then maybe there are ways to make it less so. All right, any questions on this one? So this one is using limited information estimation, which is advantageous in that it avoids numeric integration for models that have lots of factors. It is advantageous in that you get direct indices of model fit as well as local misfit, but it is not ideal in terms of missing data. It assumes any responses are missing completely at random. So I wanted to show you what it would look like to do the same type of analyses in full information maximum likelihood instead, and I used the binary version of these items just to make the example go a little bit quicker. So this is example 7D. If you're using full information maximum likelihood, that's where we're doing numeric integration via adaptive quadrature, so like 15 points per dimension in this case. There's only one factor, so it should work okay. But M+ isn't built for this. But there is a way that you can hack it to do so, in which case the code looks different. So rather than having, let me go back to the beginning of example 7C as a point of comparison. Here we go. Rather than having a grouping variable that is explicitly identified in the variable section and then referring to the name of that under the models, we have this combination of things under the variable section. So what is happening under the hood is that we are pretending that this is a mixture model. A mixture model is the idea that you have these hidden classes of people and that you can use the data that you have to try to figure out how many classes you have and how they differ from each other. It's an exploratory technique when it's used in the traditional sense. This version is actually confirmatory. So classes equals 2. I have a variable that I'm calling group in the model code below. The variable in my data set is called female that is going to identify the classes. And then known class says, don't try to find the classes, just use this as identified by this group. So it is still functionally a multiple group model. There's no mixtures being found. We're just hijacking that architecture to be able to fit the model. So this way is full information, better for missing data, much more painful to troubleshoot misfit or non-invariance. And it also it's also potentially more difficult to estimate because we're in full information maximum likelihood, particularly for smaller samples. Under analysis, there's a couple extra things that are required here because of the mixture model architecture. Type equals mixture and algorithm equals integration. Those are options that we had to add to be able to do this. And TEC10 is the analog to the residual command that allows you to get the misprediction in terms of univariate frequencies as well as bivariate cross tabulations of each pair of items. The rest of the code has to look a little bit different too because of this mixture hijacking. So we just have one model statement, and we have something called an overall model, and note these are percent signs. So M+ has used, to my estimation, every single special character on the keyboard at this point. Percent signs are a new one for this class at least. And we have an overall model, which is going to be for the reference group. We have an alternative model, which is labeled as group 1 versus group 2. So it's this weird convoluted #2 thing separates out the particular latent classes. This is just a command to sort of separate out what comes in that group in terms of the model parameters being estimated. So once you have all of that set up correctly, the rest of it is okay. So in this is the logit of the probability of being in this group. I didn't want it to find it as a model parameter because you can just get that from the data, so I fixed it to what it should be. Then we have loadings, we have thresholds, and we have factor, mean, and variance. The same thing without the labels down here sets us up for a configural model. And here's a few indications that things may have gone awry in terms of the estimation. So actually, let me back that up here. If we look at the factor loadings, I highlighted this one. So this is a factor loading of 10 in logits with the standard error of 6. Yeah, that chuckle is correct. Why did you chuckle?
The loading being so high means that it's a massive change that's happening, but the error being so large as well means that, realistically speaking, almost the entire sample could fall within margin of error.
Yeah, this is M+4. Yeah, I have no idea what this parameter is supposed to be. Here, good luck. It's not even significant with a loading of 10 because this point estimate is nowhere near the most likely thing. So this is the kind of thing that can start to happen when you, in homework 5, for instance, for those of you who have smaller samples and you're using full information, this may happen. So if so, let us try to help you troubleshoot. Otherwise, you may just have to live with non-convergence or crazy parameters like that. It does give you the IRT parameterization in this output because this is the binary version. And then the other piece that would be new is this down here, which is the proportion of cases that are men in this case, which corresponds to a probability of 0.34, which is just from the data. So that's one additional piece that's reported as part of this output. If we do, actually, no, take that back. So where's my model fit for this? This is what I put in here. Model fit info, number of free parameters, free to not be 0, and this is it. Where'd the rest of it go? Did I forget it? Did I hide it from you? Why don't I have like an H1 model, an RMSEA, CFI, all that stuff? Answer from the Zoomers, full information cannot give you the fit, right? Right. This doesn't really have a saturated model. All of those lovely fit statistics are only possible when there is a single answer to come back to that you can compute from your data as a saturated model. In CFA, it's means, variances, and covariances estimated directly as what the right answer should be. In IFA, it is the tetrachoric or polychoric version of the correlations is the right answer that they're coming back to. In full information, the right answer is the full, it would be what, 7-way contingency table of all the possible response patterns across these 7 items. We don't have enough people to be able to fill that out, so we can't really assess absolute fit very easily using the information that's given by M+. This is again where more specific IRT packages such as FlexMIRT or the MERT within R, any package that allows you to compute M2 or RMSEA2, the limited information versions of FIT would be a better option than this, but this is all I got. So I have no idea based on this if this model fits well. However, I can still use this information to see if nested models fit worse, because I can always do likelihood ratio tests. So relative model comparisons of fit are still possible. So if I go through the process of constraining loadings, so I added the loadings on here, did a likelihood ratio test, the answer is not worse, so it looks like I could constrain the loadings together. And once I do that, loading number 4, which was 10 in one of the groups, has averaged out to 8, still has a pretty large standard error, but it's starting to behave a little bit better. So pooling the data together gives you a little bit more stability. In the threshold model, I added that one, so scalar invariance looks like it's significantly worse. Here is some information that I can use to try to diagnose non-invariance. This is the first time we've looked at this in this class. This is the residual output that's given by Tech 10. The first thing that we have is the observed univariate proportions in each response category, followed by what the model said they should be. And so I've highlighted item 3 here as the one that is relatively most discrepant in terms of not being able to reproduce the marginal probabilities of response in each category. Item 3 was the one that was flagged in the limited information analysis as well. In class 2, we see the same pattern, so for the females. And then we would have to go through like all of this plus the bivariate, every possible combination to be able to try to figure out which parameters were breaking the model. And I was like, yeah, I'm not going to do that. So the end. I got you started. If you ever need to do this in life, this is probably not the optimal way to do it, but this is at least a starting point for how to do that. If you have a structural equation model that has different items across the groups, you have to set it up this way. WLSMV will not work. If you have different response categories used across groups and you don't want to collapse them to be the same, you would have to do it this way as well. So those are some real-world limitations to WLSMV that you should be aware of. There. Questions? No, just smiles. Thanks. I'll smile back. You know why I'm smiling? Because we're done with invariance. Yay! I always feel a sense of accomplishment when I, finish a handout finally. 27 pages later.